Okay, testing. Okay. We are going to be doing, what are we on, 2.5? 2.5. So let me get this together here. I need a pencil, I need black, and I need this. Okay, so we are at 2.5. In 2.5, we need to review that we have less than or greater than symbols. We have less than or equal to and greater than or equal to symbols. And when we are discussing less than or greater than, if you remember when you used to graph on a number line, it would be an open circle, and then it would either go one way or the other. Well, now we're going to use a parenthesis instead, going one way or the other. And when you had or equal to, it was always a closed circle, and then you'd go one way or the other. Well, now we're going to use a bracket and go one way or the other. Okay, so just to review. All right, what do I mean by all this? Well, what if I had x minus 7 is less than negative 12? Instead of an equal sign, what we have is what's called an inequality. So we're going to deal with this inequality just like we would an equal sign. We still have that same barrier, okay? And we still want x is less than something. We still need to solve. Well, right now, the only thing in the way is the negative 7. So to move it to the other side, we would add. That would cancel out. You'd be left with x less than, and negative 12 plus 7 is negative 5. So there is your answer. But when you have an inequality, you can't just give the answer. You also have to show the graph and give the interval. Now the graph would look like this. It's less than negative 5. Is it equal to? No. So we're going to use a parenthesis. It's less than negative 5. So it's everything this way. That's the graph. Now remember the interval. What's the farthest number to the left? Negative 5. What's the farthest number to the right? Infinity. Infinity always gets a bracket, and a parenthesis, and negative 5 gets a parenthesis as well. So here is my answer written out. Here is my answer on a graph, and here is my answer in interval notation. Okay? Let's try another one. All right, what if I had x minus 10 is greater than negative 7? Well, here's my little wall. I need x is greater than something. In order to find that out, I need to move the 10. The 10 is negative, so I add it or make it positive. And it's gone. Negative 7 and positive 10 is 3. Now that's the answer as an equation, or what we call an inequality. I also need to have it on a number line. So if this is 0, and this is 3, and x is greater than 3, but not equal to, get the parenthesis, and it goes this way. So there it is, graphed. Now we need to do the interval. What's the farthest thing to the left? 3. What's the farthest thing to the right? Infinity. 3 has a parenthesis, and infinity gets a parenthesis as well. You know what? I just realized something. I did something wrong. Let's go back to this one. Go back to this one. This is wrong. This is wrong. The farthest thing to the left is negative infinity. The farthest thing to the right is negative 5. Negative 5 has a parenthesis, and negative infinity always gets a bracket. Well, I wish someone would have been here to say, hey, Morris, you're doing it wrong. At least I caught it. All right. Let's go back to all right, let's go back to a blank board. All right. What if I had 14 plus 2x less than or equal to 3x? Again, I have my wall, but in this case, I have x's and x's. I could move this x over here, but then there'd be nothing left. This is one of those where it doesn't matter which way. I'm going to move this x, it's a positive, so I make it negative, over to this side. That cancels out. I'm left with 14 is less than or equal to 1x or x. I'm done. But if it helps, you got to look at it. X is greater than or equal to 14. Okay, there's the equation, or what we call the inequality. I still need to graph it. It says x is greater than, the greater than sign pointing x, and it's also equal to. So it gets a bracket, and it gets shaded going this way. Okay, there is my number line. Now I need to make the interval. And the farthest thing to the right, farthest thing to the left is 14. Farthest thing to the right is positive infinity. 14 has a bracket, and infinities always get a parenthesis. All right, what if I had 3x is less than or equal to 15? Same thing. This time I just need to get rid of whatever's in front of the x. So I have to divide because it's being multiplied. So I get x is less than or equal to 5. Same thing. Here's 0. Here's 5. It's less than or equal to, so it gets a bracket, and it's everything going this way. So the farthest thing to the left is negative infinity, and the farthest thing to the right is 5. Infinity always gets a parenthesis, and 5 gets a bracket. Inequality equation, graph, interval. Inequality equation, graph, interval. All right, there's a rule. And the rule states, there's one little thing. You notice no matter what we do, everything is solved just like as if it were an equal sign. Everything, even though it's an inequality, we're solving it just as if it was an equal sign. But there's one exception. If you multiply or divide by a negative number, the sign has to flip. To be able to solve this, I would have to divide out -4 and do it to both sides. Am I multiplying or dividing by a negative number? Yes, I am. So this does not say it flips. It was less than or equal to, now it's greater than or equal to. And 32 divided by -4 is -8. That's my inequality equation. I still need to graph it. So x is greater than or equal to -8. So it gets a bracket, and it's greater than. So it's everything this way. There's my graph. Now my interval, what's the farthest thing to the left? -8. What's the farthest thing to the right? Positive infinity. Infinity always gets a parenthesis. -8 gets a bracket. And there's my answer for that one. So again, when you're solving inequalities, you solve them the same as you would an equal sign, an equation, except if you have to multiply or divide by a negative number, the sign flips. All right, in order to solve this one, I would have to divide by 5. Am I dividing by a negative number? No. I'm dividing into a negative number, but I'm not dividing by a negative number. So if you don't divide by a negative number, it does not flip. It stays the same, and negative 30 divided by 5 is negative 6. Still go about graphing it the same way. X is less than or equal to negative 6. That's everything this way. Farthest thing to the left is negative infinity. The farthest thing to the right on the graph stops at negative 6. Negative 6 has a bracket, and infinity always gets a parenthesis. This inequality, on the other hand, I have to divide by negative 9 to solve. Am I dividing by a negative number? Yes, I am. Negative 81 divided by negative 9 is positive 9. Now I graph it. X is greater than 9, but it's not equal to, so it just gets a parenthesis, and then it's everything to the right. The interval, what's the farthest thing to the left on the graph? 9. Farthest thing to the right on the graph? Positive infinity. 9 gets a parenthesis, because that's what it has, and infinity always gets a parenthesis. All right. Let's jump a little bit farther. Let's have a bigger one, bigger inequality. What if I had negative 3 times x plus 4 plus 2 is greater than or equal to 7 minus x? Same as if you were doing an equation. The first thing we do is simplify the left side. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. And we have plus 2. Combine like terms. Negative 3x minus 10 is less than or equal to. I'm just bringing this down because do you see, is there anything you can simplify on this side? No. Have we simplified all of this side? Yes. Is this side simplified? Yes. So now we start moving things over. I want my x's to be all by themselves on the left. This is a 1, so it's a negative 1x, so I'm adding a 1x. It's gone. Negative 3x and positive 1x is negative 2x. This 10 needs to go over there, and it's a negative 10. So I'm going to add it. I get negative 2x is greater than or equal to 17. Now I have to get rid of the negative 2. Am I dividing by a negative number? Yes, I am. So the sign flips. And I get negative 17 halves, or negative 8 1/2. That's the equation. Now I still have to graph it. So here's 0. Here's negative 8 1/2. And it says x is less than or equal to. So it's a bracket going this way. And then the interval, what's the farthest thing to the left? Negative infinity. What's the farthest thing to the right? Negative 8 1/2. Infinities always get parentheses. Negative 8 1/2 gets a bracket because it's right there. Okay. All right, let's try one more. 5 minus 2 times x minus 4 is less than or equal to 11 minus 4x. All right. We need to distribute. Notice what we're distributing. We're distributing a negative 2. So that 5 doesn't change, but negative 2 times x is negative 2x, and negative 2 times 4 is positive 8. And there's nothing to do on this side. I can combine like terms. 5 and 8 give me 13. Okay, now I want my x's on this side, so I'm going to move this 4x over by adding it. The negative 4x, I add it. That gives me 13 plus 2x less than or equal to 11. I want this 13 to move over there at a positive 13, so I have to make it negative 13. And that's what 2x is less than negative 2. Now, am I dividing by a negative number? No. So I do not flip the sign. X is less than or equal to negative 1. We've got the inequality equation. Now we just need it's less than or equal to negative 1. Okay, so the farthest thing to the left is negative infinity. The farthest thing to the right is negative 1. Infinity always gets parentheses, and negative 1 gets a bracket. All right. What happens if I have this? 3 is less than x plus 2, which is less than 8. This is the last part of 2.5. You're going to have, what you need to see is this is actually one equation and two equations. So we separate it out, and then we'll put it back together when we're done. Here, in order to solve for x, I would need to move this 2 over. Oops, that's a positive 1. And I would get x is greater than positive 1. Here, I would have to move this 2 over, and I get x is less than 4. So now put x in the middle and put it back together. X is greater than 1, but less than 4. So let's look and see what that looks like on the number line. Here's 1, here's 4. X is greater than 1, but less than 4. So it's everything in between. So what's my interval? What's the farthest thing to the left? 1. What's the farthest thing to the right? 4. And they both have parentheses. So even though it's called a compound inequality, we separated them, brought them back together. We had the equation, then we graphed it, and then we did the interval. Let's try another one like that. Let's look at another one. What if we had negative 1 less than x minus 2, which is less than 3. So we have two inequalities. Negative 1 is less than x minus 2, and x minus 2 is less than 3. To solve for x here, I would move the 2 over, and I get a 1. X is greater than 1. Here, I would move the 2 over, and I get x is less than 5. So if you put them together, bring this and this, and there's your equation. We still have to graph it. There's 1, and here's 5. It says x is greater than 1, and x is less than 5. So do you see how they come together? It's everything in the middle. And the interval notation would be what's the farthest thing to the left? 1. What's the farthest thing to the right? 5. And they both get parentheses. All right, let me show you what else it could look like, though. Let's take a different one. What if we had negative 2 is less than or equal to negative 3x minus 1, which is less than or equal to 5. All right, we're still going to separate them out. Negative 2 is less than or equal to negative 3x minus 1, and negative 3x minus 1 is less than or equal to 5. In order to solve, I'm going to move the 1 over to its other side. Goes away. Negative 2 and positive 1 is negative 1, and that's less than or equal to negative 3x. Now I need to divide. I'm dividing by a negative. When you divide by a negative, what happens to the sign? It flips. And a negative 1 divided by negative 3 is a positive 1/3. All right, let's look at this one. Here, I would have to move the 1 over. So I get negative 3x is less than or equal to 6. Divide by negative 3. Again, I'm dividing by a negative number, so my sign flips, and 6 divided by negative 3 is negative 2. Put it together, and it looks like this. Graph it, positive 1/3 would be on this side, negative 2 would be on that side. It says x is less than or equal to 1/3, but greater than or equal to negative 2. So, what's my interval? The farthest thing to the left is negative 2. Farthest thing to the right is 1/3, and they both have brackets. All right, let's try one more of those. Okay, one more. Let's do negative 2 is less than negative 4x minus 5, which is less than or equal to 7. All right, our two equations are negative 2 is less than negative 4x minus 5, and negative 4x minus 5 is less than or equal to 7. Here I would need to move my 5 over. So I get 3 is less than negative 4x. Divide by negative 4, I'm dividing by a negative, so my sign flips, and 3 divided by negative 4 is negative 3/4. Okay, over here, I'm adding 5 to both sides. I get negative 4x is less than or equal to 12. And then I divide by a negative 4. Again, I'm dividing by a negative, so what happens to the sign? It flips, and 12 divided by negative 4 is negative 3. All right, let's see what this looks like together. You put x here. You got greater than or equal to negative 3 and less than negative 3/4. All right, negative 3/4 would be here, and the negative 3 would be to this side of it. It says x is greater than or equal to negative 3, but less than, not equal to negative 3/4. Notice the two different symbols, because one is just an inequality that just has greater than or less than. The other one has also equal to. So what's the farthest thing on the left? Negative 3. What's the farthest thing on the right? Negative 3/4. Negative 3/4 gets a bracket. Gets a parenthesis. Negative 3 gets a bracket. Done, done, done. And that is 2.5. Okay, so we are done. And I will see you again.